Suppository, the types of bases used in the formulation of suppositories, the method of preparations, and the pharmaceutical incompatibilities. So these are the topics that I will discuss today. So now I will start my presentation with the introduction part of suppositories. Suppositories are the dosage form that are introduced into body cavities, and they are prepared either utilizing semi-solid bases or solid bases. And the preparations prepared by employing the semi-solid bases are turned to solid forms by treating them under low temperature. And the semi-solid forms does not have proper shape and face ability to produce into body cavities. Thus, they are defined as solid masses, although prepared by semi-solid bases. Suppositories are defined as solid bodies of various weights and shapes intended for introduction into body cavities except mouth cavity. Usually rectal, vaginal or urethral cavities are utilized, where they dissolve or melt and release their medications and exert their drug effect, like promotion of laxation, like glycerine suppositories, the soothing of inflamed tissues, like other medicated suppositories used to relieve the discomfort or hemorrhoids, and or the promotion of a systemic effect like aspirin suppositories. So this is the general introduction of suppositories. Next, I will discuss about the merits and demerits of suppositories. So merits, they are used to treat the local conditions such as hemorrhoids in rectum and infections in vagina. Since the drug is absorbed from mucous membranes, and they have been used for systemic absorption when the oral administration of drug is not feasible, as in case of infants or debilitated patients, and in conditions like nausea, vomiting, incapability of swallowing, and other gastrointestinal disturbances. They have been used to obtain prolonged action of drugs. They provide faster onset of action than is found after oral administration, and because absorption of drug from the rectal mucosa is directly into the venous circulation. They save drugs from the degradative effect of gastric pH and enzymes, since they
avoid the gastric and hepatic route, and they are unit dosage forms, hence there is no dose variations. They are found prompt in action if prepared with appropriate bases, sometimes considered as equivalent as parenterals. The demerits are they are required to be stored at freezing temperature throughout its shelf life, otherwise their shapes may be distorted. There is leaking problem of material through cavities, thus found uncomfortable, and their administration is inconvenient to the patient. Absorption of drug through rectum is irregular, and these are the merits and demerits of suppositories. Now the types of suppositories, there are different types of suppositories like rectal, vaginal, urethral, nasal and ear cones. So the first one is suppositories are introduced to different body cavities, and they are named on the basis of cavities into which they are introduced. First one is the rectal suppositories. These are solid masses of various shapes such as cones, torpedo, bullet, etc., and weights intended for insertion into the rectum. The weight of the suppository varies from 1 to 2 gram, and they are also called the rectal suppositories after the name of body cavity to which they are introduced. It is available in different shapes and sizes, and the pessaries, it is also known as vaginal suppositories. Pessaries are the solid masses that are intended for the administration into vagina, and they are also called the vaginal suppositories. They have different types of shapes like cone, round, apex or wedge, and the weight of one pessary varies from 4 to 8 gram as the case may be. Generally, the drugs are administered to the vagina for a local effect only, and but it must be kept in mind that systemic absorption can also occur. The common constituents of vaginal suppositories are antiseptic, contraceptives, and various other drugs used to treat trichomonal, monilial, or bacterial infections. To facilitate the insertion, it is advisable to dip the pessary into water before the administration into vagina. Urethral bogies, they are solid masses intended for the insertion into urethra. They are long, thin, cylindrical in shape with round apex, and usually they are about 6 cm long and have weight from 1 to 2 gram. They are also called the urethral suppositories. Nowadays, they are obsolete formulations. Nasal bogies, they are solid masses intended for the insertion into the nasal cavities. They are long and having round apex and prepared with gelatoglycerine base, and the length and weight is usually not more than 8 cm and 1 gram respectively. Ear cones, they are solid masses also called urinaria intended for insertion into ear, and their shape is long and cylindrical and prepared with cocoa butter. They usually contain lubricants and anti-inflammatory drugs. So these are the types of suppositories, and the next one is a suppository bases. Suppository bases exert influence on the action of drug that have been distributed or dissolved in them. The drug must be released from the bases, rapidly dissolved in the fluid of cavity, diffused to the rectal mucosa membrane, and enters to the bloodstream by passive diffusion. Thus, the suppository bases are of prime importance, since more rapid is the release of drug from the base, faster will be the absorption. So the first one is oleaginous base. Cocoa butter or theobroma oil is the most widely used oleaginous suppository base. Since its introduction as base in 1852, it is a mixture of glyceryl esters of stearic, palmitic, oleic and other fatty acids. It has various advantages as a suppository base, like it is a firm solid at a temperature of 32 degrees centigrade. It melts between 34 to 36 degrees centigrade and produces a thin blend oily liquid. Thus, it melts in the body. It readily forms liquid on warming and rapidly sets on cooling. Next one is a aqueous base. Aqueous bases are water soluble and water miscible. They are of three types, like glycerogelatin base, magrogel bases and soap glycerine bases. So the first one is glycerogelatin base. This is a mixture of glycerol and water along with gelatin, and the latter provides stiffness to the base. This base is suitable for suppositories and pessaries, and the stiffness can be manipulated by adjusting the quality of gelatin. Macrogol base, they are also called the carbovaxes, and they consist of the mixture of various varieties of polyethylene glycols, and they have following advantages as suppository bases. The first one is they have melting point above 40 degrees centigrade, and hence cool storage is not required. They are found suitable in hot climates and easy to handle as they are not slippery. The third one is the soap glycerine bases. Soap glycerine bases for suppositories are prepared by mixing soap and glycerine, and soap is used as hardening material as in case of gelatin in glycerogelatin bases. Sodium stearate up to 95% of glycerine can be incorporated or can be produced in situ by interaction of sodium carbonate with a stearic acid. And the third one is a synthetic fat bases. Synthetic fats are developed as a suppository base to remove the disadvantages of cocoa butter, which is only the natural fat with suitable properties for suppositories. The next one is the emulsifying bases. Excellent qualities over all other suppository bases, like they are not rancid, hence more stable. They do not adhere and good solvent for drugs, and they have attractive appearance. They are non-irritant. They are compatible with a wide range of medicaments, and the difference between the melting and setting point is hardly 1.5 to 2 degrees centigrade. Thus, there is no question of sedimentation of drug. So the next one is the displacement value. Displacement value of medicament incorporated in the suppository base is needed to find out the displacement of equivalent amount of base with the amount of medicament so as to adjust the medicament in the same volume of the cavity which had been calibrated using base alone. It is required since the densities of medicaments are different from the densities of bases. Therefore, although the volume of suppository from a particular mold is uniform, but its weight will vary because of the differences in the densities of medicaments and the bases. The displacement values of medicament become useful in calculation for the quantity of bases, and the displacement value of any medicament can be determined by the following method. Like find out the weight of 5 suppository of plain cocoa butter. Let A into G, and find out the weight of 5 suppositories say containing 20% of medicament, so let B into G. Calculate the amount of cocoa butter, that is 80 into 100 into B, let C into G. Then calculate the amount of medicament, that is 20 upon 100 into B is equals to D into G. So calculate the amount of cocoa butter displaced by the medicament D, G, that is A minus C, G. So the displacement value of medical and value of medical and incorporated in the suppository base is needed to find out the displacement of equivalent amount of piece with amount of medical and so as to adjust the medical and in the same volume of the cavity which had been calibrated using a base alone. Next one is the general methods of preparations. These can be classified according to the base used. So suppositories with a fatty base, example cocoa butter and synthetic fats. Suppositories with a glycerogelatin base and suppositories with a macrogel bases. Suppositories with a fatty base, this can be further classified according to the physical type of the drug used. It includes the suppositories containing insoluble solids and suppositories containing solids soluble in base, suppositories containing semi-solids, and suppositories containing liquids. The next one is suppositories containing insoluble solids. So follow the following general methods, like calculate the quantities required, taking displacement value of medicament into account. Always calculate the quantities of material for 2 extra suppositories to avoid losses occurred during preparations. Losses occur during preparations. Select a dry, clean mold and place it on a clean tile. Shred the fat, weigh the required amount and place in the smallest evaporating dish. Porcelain dish is preferable because it is easier to heat the contents in a metal type, and finally powder the medicament and pass each through a separate sieve number 180 and weigh the required quantities. Heat the tile until becomes warm to the hand. Mix the powders on the tile with a flexible spatula and place the base on the water bath until about 2 to 3rd of the contents has melted, and then take out of the heat. The rest is melted with the constant stirring. Pour about half of the melted base on the mixed medicament and start levigating to form a smooth dispersion as quickly as possible. If the base solidifies, it can be softened by holding the tile over the water bath for a few seconds. Transfer the dispersion to the dish and stir to form a homogeneous mixture. Continue stirring until the mixture begin to thicken, and then fill each cavity of the mold to overflowing, and stirring must be continued during filling to avoid sedimentation of insoluble solids in melted mass. Leave for 2 to 3 minutes until the mass has just set, and then remove the excess from the mold with a sharp knife and the razor blade or a slightly warm spatula. Leave in a cool place for 10 to 15 minutes. Finally, open the mold and remove the suppositories. So this is the general method of preparation of suppositories containing insoluble salts. Next, the pharmaceutical incompatibilities. If we discuss about the pharmaceutical incompatibilities, so the incompatibility means when two things are not required together due to any of the case, so it is called the incompatibilities. And these are so many ingredients and drug which have been used to produce many formulations. There might be the chance that a few of them with their physical, chemical and therapeutic properties can alter safety purpose and appearance of the preparations. Henceforth, we can define pharmaceutical incompatibilities as untoward result occurred by prescribing, giving or mixing of substances and drugs which are antagonist in nature. So the incompatibilities may be classified mainly into three classes. The first one is therapeutic incompatibilities, physical incompatibility and chemical incompatibility. Physical incompatibility are those preparations which lose their safety, appearance and therapeutic purpose due to some of the physical properties of the drug and additives like immiscibility, insolubility and liquefaction of solid materials. The characteristic of substances contribute to the unsightly, non-uniform and unpalatable mixtures. Such mixtures are not to be accepted by the pharmacist, and pharmacist should be able to detect or predict the possible reasons of incompatibilities. Next one is the physical incompatibility. This is compatibility. Example of physical physical properties like immiscibility, when two such ingredients are combined resulting in a non-homogeneous product. Such ingredients are called immiscible to each other, and the phenomena is called immiscibility. A very common example is the combination of oil and water. When they are mixed and shaken together, oil phase is completely separated with water phase on keeping it aside for a short time. Insolubility, certain substances have poor solubility in water and they cannot even diffuse in the vehicle system. If such systems are being prescribed by the doctor, then the pharmacist has to solve this incompatibility by using some suspending agents to suspend uniformly the particles of such substances for a sufficient period of time after shaking. The liquefaction means the formation of eutectic mixtures, which is formed when certain low melting point solids are powdered together. A liquid or soft mass is produced due to lowering of the melting point of the mixture to below room temperature. Second one is the chemical incompatibility. Chemical incompatibilities are those preparations which lose their safety, appearance and therapeutic purpose due to some of the chemical properties of the drug and additives like pH change, double decomposition, oxidation reduction, acid-base hydrolysis and complex formations. These various types of chemical reactions may result either in precipitation, effervescence, decomposition, color change and explosion. If the chemical reaction take place immediately after combining, the precipitation